Water, the one vital ingredient that all plant life can't do without. But sometimes the very thing that gives life can also take it away. In many parts of Australia, water also brings salt. Although many plants can survive on salty water, soil cannot. Associate Professor Greg Leslie from the University of New South Wales School of Chemical Sciences and Engineering is taking the first steps to helping solve this problem.
Water is a big issue in Australia. It's probably one of the, next to the greenhouse problem, how we manage our water is really the big issue that we've got to address to support our population now and into the future.
Extracting salt from salty water and then getting the water to plants in an astoundingly efficient and simple way.
So what we're looking at here is a channel. This would be a tube that has a window in it, and the window contains a small piece of reverse osmosis membrane. The soil hasn't been watered in over 3 months. The only way the plant gets water is to suck water out of the tube across the membrane. That limits the amount of salt that goes into the soil, and the plants continue to grow.
One of the most ingenious aspects of the system is that it requires no external energy at all to run.
In drier years, farmers can use the poor quality water to continue to produce a crop with this technology. In the wetter years, when they would just use regular irrigation techniques, the material, probably made from a cellulosic base, would just break down and stay in the soil.
Greg's reverse osmosis membrane technology supplies water directly to the roots where it's needed most, minimising waste and, better still, using the plant's energy alone to function.
The implications are that we would arm farmers with a technique that they could use in dry years when they don't have any water available to them except brackish groundwater. They could use that groundwater to still produce a crop, but without damaging the soil, so that the land would still be productive when surface waters return to when surface water becomes available.
The system is proving effective for most common market garden crops and is expected to be in production within the next few years.